Hi, my name is Alex Thibodeau, and welcome to the Kenway Corporation here in Augusta, Maine. Where a division of Kenway Corporation, temperature-controlled mold composites, has produced a temperature-controlled mold. The impetus and driving forces behind producing this temperature-controlled mold was the ability to finitely control mold temperature and to provide unlimited flow time for vinyl ester resin into the composite materials. And then when we're sure that the part has filled to the level and to our satisfaction, we then can turn the temperature up and cause the cure cycle to begin. And as the cure is continuing on, we can also control the rate at which it cures, maximum exotherm temperatures, and be able to make sure that we are keeping in check all of the parameters necessary to produce a high quality part. The benefit of our product, or our table and temperature controlled mold, is multifaceted. Certainly one of the biggest things is it allows you to use vinyl ester resins or epoxy resins, whatever your process requires. But because our process also utilizes a controller with the resin, it allows you to infuse your resin at a much higher temperature, drops the viscosity significantly, which gives you a faster fill time and certainly a far more thorough and complete wet out of all of the materials inside of the mold. So we have the reservoir, the water reservoir, which you can see, and the control panel. Turn the unit on, and what you'll see here, the first number that'll come up is the temperature that the table is actually at. So right now the mold surface is at 144. The set point, we can see what the set point is by either hitting the up or down button. We see the set point. If I hit it again, is 145. It's at 144, so you can see the heat light has come on in order for the heating unit to heat up the water that's in the reservoir to keep that mold surface at a constant 145 degrees. If we want to go warmer, we simply just hold down on the set point up button, let off when it reaches the temperature we want to be at, which I set it to 160. We're at 144 and the heat will remain on until it gets to 160. If it goes past 160, then the chiller unit will take over and drop the temperature back down. It's all about the finite control. We realized that we had to control the amount of input heat and then control the temperature throughout the entire process. And the only way to do that was the temperature control molding. There's no other way.
Especially in thick laminations.
Right. We've done 7.5 inch thick lamination, and without issue. And then we produced one part that was 1/2 inch thick on one end. It was a wedge, 1/2 inch thick on one end, 7.5 on the other, and got a perfect cure. Josh is making sure that that we've got enough material in the transitions of the mold and that we're pulling the part down evenly onto the mold. And now Matt shut the vacuum off just prior to the bag being completely drawn down, so that he's going to go back, make one more check, make sure we haven't wrinkled the glass, that it's still laying in there nice and flat, and that we've got the proper amount of bag material and any of the geometric transitions. Our intent really is to sell the technology and license the technology, and that we will produce parts if the customer, that's what they want. But our real intent is to produce the molding, then support the customer in how to apply it, how to use it, how to successfully build their parts, how it can benefit their process or their industry, and then they own it. It becomes a tool within their shops. And then we provide forward-going support on, an on-call as-needed basis. So a lot of skepticism in the beginning, and the general sentiment still was, if it's really true, this would be a wonderful thing, and I could see many applications in my shop. At this point, the part's completely full. We've reduced the vacuum level to a level less than full vacuum to ensure that styrene boil-off does not occur. And we turn the temperature of the mold up to approximately 180 degrees F. And we just continue to monitor the part until it cures. Well-prepared mold releases incredibly easy. Part is about 90% released at this point. And there it is. We've proven that even on the most simplistic parts and hand layout, we'll produce a better part on a temperature-controlled mold than on a cold mold. So what we're doing now is trying to prove that the technology, that not only can we do it, but shops can apply it in their own applications with a high, perfect success.
Exactly.
It's not a theory anymore, it's proven technology.